use a rid template command to generate the Flutter app. And the reason is because it is actually quite involved to set this up. And so I don't want anyone to have to do this by themselves. So there is a rid template thing that I have in my repo, which will most likely become a command of the rid CLI tool eventually. And there's a setup command in there. And so I can set up and I can say, I want you to set up a Flutter app that is kind of set up to use with Rust and rid, and I call it to do. So that's what we're going to do right now. And while it's running, I can explain a little bit what's going on. And actually I can show also, but if there are any questions, also let me know, because this is a good time. So what's happening right now, what it's generating is something like this. So there are folders like this you're used to, right? That's going to be the main app. That's on the root folder. And for Android, actually, it's really easy to even with Flutter to load basically dynamic libraries in. It's like not much different than from Dart, except that you have to make sure to generate the right one, and there's something called the JNI libs. And I don't want to go into too much detail there, but you have to basically install some tooling, but it's fairly simple. But in order to work with macOS and iOS, we have to actually implement a plugin, otherwise it doesn't work. So what the setup script right now is doing is setting up this plugin. And all the generated stuff that we looked at, the bindings and all the stuff, is actually generated into here. So our app doesn't even mostly see this. All the basically the libraries, the dynamic libraries, are also going to be put into these folders, and our app will basically just use this plugin in order to basically gain access to the Rust code. And I hope that kind of makes sense. And so right now, basically, what it does is setting this up still, and what it's doing, it's basically building for iOS, it's building for macOS, it's building for Android, and it's using a bunch of there are two projects that basically make that a little easier that it's using under the hood, and at some point it will finish. And the thing is that every time it does it, it has to recompile because it's for a different architecture, right? And then you can see here, this is like our starter Rust code, and in this case, it's going to be a counter app. And actually, what I'm going to do is I'm going to quit this one now. No, I don't want a full screen. I want to close it. And because we don't need it, we're going to put our app that we're actually going to be working on there in a second, right? And let's see when this finishes. Border bunded. I don't know how that's related to the stream. So please refrain from posting these kind of comments. It's not related to what we're doing. Okay. So now we have our app set up. Okay. And we're pretty much, I'm going to open this over here. We're pretty much able to run it. So what was created for us, there were a bunch of scripts created for us, basically to compile for Android, to compile for iOS and macOS, and also there's a clean script because not related specifically to rid, but Flutter sometimes gets confused a little bit with plugins and kind of like sometimes there are some like files that it thinks are up to date, but they're not, and then things don't work, and you get build errors. And then basically what I recommend is just run clean, and basically we'll just run clean in the plugin folder and in the main folder, and then you usually should be good to go. What we can do now is we can run bindgen, which it kind of already did. I think it does it basically when the setup script runs, and you can see that since this is a counter app, it's generating all kind of bindings related to a counter to a counter app. So we can see here we got, let me see, count, read model count. We got ink, and we're going to see in a second what it actually does. And I'm going to actually just run it on Mac, and it should actually be already set up. We'll find out. So we should be able to already run it. And since we're not changing, well, we want to change the Rust code one time, so we're going to have to do this once again. And by the way, if you run into problems and you clean, you should then be able to see running pod install. If you don't see that, that means it didn't properly reset. So this usually means that it did properly reset, and it's now basically starting from scratch, and then everything should just work. And again, this is not like anything that's specific to rid. It's just a plugin with Flutter kind of thing. So let's wait for this to start. And as you can see, it's taking a while, but once we have it running, right, and once we have the Rust code running, we don't actually have to do this over and over. So, okay, let's see, this is just all something that's not really a problem. And we can see that actually this works, right? And you can see also we're printing on the Rust, and we can add 10 as well. So this is like the counter app that I basically created as a starter project, because everything usually in Flutter starts with the counter app, right? So we can look at what this is. It's just a really simple thing, very similar to the the other counter app, except that what it does, it delegates to Rust, to the model, right, and sends messages to do things. That's all. But we're not happy with just a counter app. We want to basically implement our app. So, okay. So I copied. I thought I had this still on my clipboard. So let me actually cat this from the Dart to do source lib, and we're just gonna copy that. All right, and now. Boom. That's what I wanted to do, right? So now we basically have this. Now it's going to complain though. Well, it normally would complain, but it's not, because everything is already set up, right? So you already have the dependencies set up and so on. The RID template for Flutter. Pega Prime. As I mentioned, the RID repo itself is not yet open sourced. So actually, let me go there just to make that clear. So let me actually open this up in GitHub. Oh, actually, I can't here. I have to actually do it. But I'm actually logged in. GitHub, and it's actually here. RID, and that's where the template is. As you can see, this repo is private, and the reason is because I don't want to just open source it and then not be able to maintain it. Right, because a lot of work already went into this. So what I'm trying to do, and I can go into more detail later. I want to kind of build the examples and then answer more questions. And I'm sorry that if that is not cool, but if I was just to open source it, then I don't know how I would maintain it. There's still so much work that has to go into it. What I'm trying to do is to try to get people that are actually really interested in this to sponsor me. And these people, whoever sponsors me, gets immediate access. So if you were to sponsor me right now, after the stream, I would give you access to the repo and you could use it and whatever. Once I reach 60 sponsors, which is my goal, which I feel like then I can actually spend enough time to I actually have enough financial support for this, then it will open source it to everyone, right? So it will just be private until I reach my sponsor goal, right? So I apologize for that, but that's unfortunately I have to do it. Otherwise, it would probably just go kind of dormant, right? Because I couldn't put the time in to do all the work that's still needed, right? Okay, I hope that answers the questions and doesn't make you too sad. Okay, now what we're going to do, we're going to basically start from scratch in the main Dart, because we don't really need the. Let's just remove this part here. We want to kind of like just start from fresh, and just basically do it like that. So what we're going to have to do, first of all, what we're going to do again, we're going to have a main function. And we want to basically just first of all get a hold of the model, right? So we're starting our app, and we're going to just basically get a model. And we have the same story that we had in Rust, right? In Dart. We're going to just init the model, right? The methods are always still the same because we're using the same Rust code. Okay, that sounds good. Thank you. Now what we're going to do, we're going to set up. We're going to just add some. We're going to just, okay, so it's still confused. You see that? It's still confused. It's still thinking that there is an add message, right? So what I'm actually going to do is I'm going to close this, because Vim sometimes, and it might be different in a different IDE, it doesn't get, or maybe it's because I did not build yet. Did I build? No, I did not build yet, did I? Okay, so that's what I'm going to have to do. Let me actually go ahead. And in this case, I call it bind gen, right? It's the same thing as build. We're generating the bindings. And you can see all this after applying the template, all this works kind of out of the box. And then now we have these things. Okay, so now we added to do learn Rust. That's what our application is. And so what's complaining? Okay. And then learn Flutter. Probably not in that order. Flutter's a little easier to learn probably. And then you want to, but then you want to learn rid. And then finally, I want you to have a lot of fun, right? And so at this point, we are we could basically print out you could print out the to-dos, but I mean we want to build a real Flutter app, so we're going to have to do a to-do app, and we're going to say that this extends the stateless widget. All right, and now we're going to have our editor help us a little bit. We're going to add the what? That's not what I wanted. I want to implement. This is what I wanted. Yeah. Okay. Okay. And again, in order to not run too much out of time here, we're going to glaze over a little bit the uninteresting parts, right? So all we have to do here is basically create a material app with a to-dos page, right? And we're going to use this. You cannot really see that we need the model, right? So the thing is now, what is a model type, right? If we want to say final model, right? And it's going to be passed in by the constructor, we have to know its type. We can glean that from here, right? Or we can just say add the type annotation and copy it, right? Well, that's not how much I wanted to copy. All right, so here we can do that. We can do the model. We can then say generate that constructor for that. And but we don't want it to be optional. It needs to be required, right? Model. Okay, so now we got that, and now we just need the to-dos page, right? So the to-dos page we implemented first as a stateless widget and then converted because that's usually the quickest way to do this. So we're going to implement the missing override. Again, not the right key. And so that's what we do here. This one will also take the model, right? And it will also take a title, which we'll pass in. You can see that here, right? So let's just copy that from here. And let's add a string. Now this is not that exciting if you have done Flutter before, but we have to kind of work through this a little bit. And then if this is too slow for everyone, let me know and I can copy and paste more code. I just don't want to glaze over too much stuff so we don't understand at all what's going on anymore. So let me create that constructor. And that's pretty much all I need here. And then, as I said, isn't used. Yeah, I don't care at the moment. And what I want to do now is actually want to convert it to a stateful widget. And then we get a bunch of boilerplate generated. Okay, so now we are set up correctly. What we need to do when we create the state, we need to post. This is the last time I pass the model down. So this is this state basically is what has access to the model. Things below it shouldn't have access to the model, and I'll show how to basically go about that. So what I need to do is I need to add this to the constructor. All right, and then here we pass it through. Okay, and so okay. Everything clear. This is pretty for Flutter. This is pretty straight up stuff, right? So now what we need to do is first of all we want to do is basically render a scaffold, and we just want to basically render a to-dos view, and we want to maybe render the title. So I'm just going to copy that because, again, as I said, some of these things are just fairly boring. So and kind of repetitive. So here we got the scaffold and then the save area. And the save area, obviously, we need for the iPhone because the Nook, right? So then this one requires a to-dos view, which we'll implement in a second. And it requires to-dos. Where do we get the to-dos from? Well, for now, we'll just show all the to-dos, right? We won't worry about the filter yet. And so we're going to get the model. Actually, we're going to do this doing the build dot to-dos, right? And that's pretty much what that will do. So now we have a problem here. Title. Let's see. Oh, it needs to be required, I think. And the same this one. And I think I know what I did wrong. I want to actually make those just parameters, just plain parameters, and probably in the different order. Yeah, the model first. Okay. Okay, so that's pretty much all we have to do here. Okay. So now now we need to implement that to-dos view. Okay, so let's go into our lib and let's add a lib, and let's say we have views, and so we have a to-dos right, to-dos view here. All right. What happened here? Let's try this again. Somehow it got confused. Okay, so, and I have no idea what happened here. Let me actually remove that and create this again. I have no idea why that. Okay, much better. Now I'm going to actually go ahead and copy and paste some of this code in, and we'll just explain through it in order to not spend too much time doing this. I'm also going to first of all, we're going to just render the title. So we don't have the to-do view yet. And actually we don't want this one. Actually, I want to implement by hand because it's nice to explain. So we'll start here, and I'll explain how this all works in a second. So for now, we're basically just going to return text to-do.title. Okay. So okay, so now this is complete. Okay, let's think about what's happening here. So we're getting the to-dos, which is the vector, which is a kind of a pointer, but since rid gives us some extra magic, we can actually treat it as if it was an iterable, and you can also index into this vector, right, or into this collection. And so what we're basically doing, we're using the list view builder, and we give it the to-dos length. The advantage of a list view builder is basically that it doesn't render anything that's not in view, right? It basically renders it on demand. So which also means that if you have a bunch of to-dos, they never even have to get from Rust to Dart, right? So we're saving a bunch of in performance there. And then we render the to-do title here, right? Now, if this was too fast, let me know, and I'll correct this. And I'll explain in a little more detail. But let's import this, and then this one is not here yet. This one we'll implement in a second. To-dos. Okay, so actually what we'll have to do is, because this is actually expecting to get a different kind of pointer, which is actually disposable, right? And this is how it's implemented. Actually, let's correct that. What we want actually really is we want the filter to-dos, right? That's actually what we really want. And as you can see, this is a different type. And you might ask, like, why is this a different type? Well, because as we saw later, we're going to have to dispose it. So the other type we didn't have to dispose, and that's why it's different. I hope that makes sense. So now we actually can run this almost. Let's see why we still have an error here. So model, 2 positional, expected, 1 found. Okay, so this is not, so we just do this like that. Okay, and now we should be able to basically, we ran the build before, and then we can just run back. So just to be sure, like what this is doing is not magic. All it does, it runs Flutter devices, and it figures out which one is a Mac OS one, and then it just uses that. So I don't have to always do that. All right. So now it's starting up our application, and most likely, since we are not going to change the Rust code, right? This is pretty much done. We can now basically from now on just keep this running and improve as we go, right? This is kind of the nice. Now we can benefit from the. Okay, so it looks like we didn't do the build yet. One thing I want to point out, in case you're wondering, what is this? For Swift, Swift tries to be really, really smart and tries to basically tree shake everything that it it thinks you don't need from the binary. So what you actually have to do, you have to generate code in order to, and that's what rid does. It basically prevents a tree shake. It basically pretends that we're actually using it, or we are using it, but it makes sure that Swift knows about it. And so, but now the binary actually doesn't have this yet. So we actually need to build for macOS, and then and you can see how fast that was. And now it should be able to work properly. So let's see. Okay, let's wait a little longer. And again, this startup takes a little bit, but once we have it started up, which it did now, we are fine. So we're not rendering anything, and we'll find out in a second why. But we have an app running, an empty one, but it's an app. So now we can go back to the main Dart, and we actually find out why we're not seeing anything. It's because we're not we're not rendering a widget yet. So we actually have to run the app, right? Run app, and to do. I wonder if that goes without restarting, but Flutter does kind of wonder. So basically, we run the app, we pass a model, and that should work. So let's see if we do hot reload. That didn't work, but if we do hot restart, okay. So that worked. So now we got the title there, and we got our list of to-dos, right? Which came from Rust. Okay. So so next thing I want to do is just like to make it look nicer while we're working on this. I'm going to basically copy out some code which is just really boilerplate, kind of normal UI code. And I'm just going to use it, right? So you don't have to watch me do it because that's pretty basic. So what I'm going to remove for now is this, because we're going to implement that in a second. And so that's why, well, we can't do this yet. So how do I remove this? Remove this. To remove hopefully does take, oh, well, that didn't work. Well, let me just do this manually then. So what we actually want, we just want a list tile right here. Okay. And so that should be all working. And we don't need this on toggle yet. Okay, so that is that. So now here, instead of just rendering the title like this, we're just passing the to-do view, and we're going to import that. And now everything should just work. So let's refresh. And it didn't. Maybe because we added a new one. Okay, there you go. Now it did. So now it looks a little nicer, right? It doesn't do anything yet. And you could see that we had the inkwell there, which allows us to click on things. And that's basically what we're going to have to implement now. Basically what I want to do is I want to be able on this to-do to click on it, right? And then basically make it do things, right? I want to be able to click on it and therefore like this completed, right? So what we're going to do is we're going to wrap it again. So we just removed that widget and we're going to put it back. And so it's an inkwell, right? And so okay, so we could have actually left that there. So nothing should have changed yet, right? It's also the same. And then what we're going to do here on that inkwell, we're going to say on, I think it's called tab, right? Yeah. On tab, we actually want to toggle this to do, right? So we want to kind of call something called on toggle, right? And so what does tab actually take? It's a gesture callback. We can't look at it, but it's basically a function like a void function. So that's what we need to get here. So we're going to take a void function and called on toggle, right? And then obviously we need to add it to the doesn't allow us to do that yet. Let's see here. Add this to the constructor, and this one we want to make named. So we require it and make it like this, so we can name it, pass it in. So that would now allow. So if we click this, we call this on toggle, and then obviously now when we are in the to-dos, we need to pass it in, right? So and basically what it's fairly simple, right? Basically what we have to do here is we have to We don't have the state here. We don't have the model here. So we actually need to also pass back what was clicked. So we can actually copy this one, but it's a little different, right? Because we target a specific to-do, and therefore we need to take the ID as an int, right? So now if I add that to the constructor, and again I make it also a named field, right? So now we can actually say here on toggle, right? What you want to do is you want to call on toggle to do, and you want to basically take the to do ID, right? And that's it. That's all there is. So basically we have the do, we have the ID, we pass it back, which one wants toggle. And this is kind of similar to you could think of it as like dispatching events kind of up the chain. If we were using something like a block pattern, we wouldn't have to do it manually. But I'm doing it this way and to make it really easy to understand and really obvious. And the thing is, what I would highly discourage is to directly work with the model in these lower widgets, right? What you would want is, for instance, if you use block, well, then the block could have access to the model, but we don't want to, in our views, like in the middle of everything, just like access a model. So instead, what I'm going to do here is I'm going to implement this on toggle, right? Well, should on toggle here, right? Oh, should be here, right? Yeah. And so I'm going to then modify my model, right? So we do it like we do it in the main place. Now, what we have to do is, well, actually, let me do it wrong first to get the point across. So what we have to do then is to go to the model and send a message, right, that we want to toggle this to do, and this one should have an ID, right? Let's pause this, and then we just pass that, and then we go, and that should work, right? You would think. So let's look at that. So let's toggle this one. Well, nothing happens. Let's toggle that one. Nothing really happens. So let's reload. Oh, and now suddenly it got toggled. That's odd. Well, it's because we are not telling the widget that we actually are changing state, right? So what we actually have to do, we have to wrap this whole thing into a set state, right? State. And again, this is like one way of really simply building an app which just sets state. And it works, but obviously most of you will use a different mechanism. So now this works. We can see that, right? To handle state, and I will also create examples for that as well. I'm planning to do an example with block and maybe some other state management patterns. Okay, so we basically now have a way to toggle to dos and basically show the updated state, right? Now the next thing that we want to do is we want to basically say a filter, right? We want to filter down here which to-dos we're actually looking at, and so this is we're going to put that in the bottom navigation bar, and I'm going to steal a little bit of code. How are we doing time? Okay, we're actually still good on time, so I want to basically finish at the top of the hour. So first of all, we want to add two constants here, like when we have a basically filter selected, so we can kind of see the difference that it's basically selected or not selected. And what I'm going to do is I'm going to steal just a little bit here. So what we're going to do is we're going to have the bottom navigation bar, and we're going to have these children of this row, and that should actually already work. All right, so now if you refresh it, nothing shows up yet because there's nothing here. But then basically what we're going to do, we're going to implement some icons. Some icon buttons, right? Because we want to be able to click them. Button, and then inside that button, we're going to say the icon, right? And this is all widgets. This is all kind of highly wrapped. But so here, this one is a check one, right? And this should actually already show something. So we're gonna do that, and it wants const. Does it want const? Oh, okay. So must press must be on press must be provided. Okay. So for now we provide an empty function. Okay, now it should work. So now, well, here you go. It actually now shows this button, right? So now we do the same thing for the other ones, but let's implement. Actually, let's go ahead and implement this one. But this one actually is the checked one. But let's actually start with the let's start with the checked one. It's fine. So what should happen if we check it? Well, we should first of all the color, right, should depend on the filter, right? So if the filter is with filter completed, right, then we want to say the filter, well, filter selected color, right? Otherwise, we want to show the filter unselected color. All right, so that's that. And then obviously when we press it, right? So we got the icon, we got the color. Let me actually move this here and pressed here, so we have a little bit of different order. When you actually press it, what we want to do, we want to basically, first of all, we need to set state, right, to make sure that whatever happens now, we actually then also update the widget. And then we send a message to the model dot set message as filter, and we are going to say rid filter completed, and we're going to pass the index of that. All right, so it's complaining. Okay, we do unit the filter, right? So final filter equals model dot filter. All right, so every time we build, we query again for right, because every time the state changes, we need to actually see what the state is. So now if I refresh that, now we got that, and basically now if I click it, it's selected. Okay, and also you can see the filter was already applied since we're already filtering the to-dos. Now there's no way for me to unselect this, so we're going to have to implement those. And here we'll just copy a little bit. So first of all, we want also pending, and it's just basically this. That's pretty much that. That should show up now. Okay, but except we need to show a little bit different. So there's no real pending icon, so I found something that looks like pending, and it's called calendar something today, I think rounded or something like that. So if I refresh it, now we can see that. Now all that's needed is if we're showing all of it, right? So we have icons, and so for that I found another one, all inclusive, which looks like infinity, but it works for our purposes. This is when the filter is all, and when you actually click it, then we want to set the filter to all. All right, and so there you go. Now this looks a little ugly. It's all together, so we're going to put a spacer in between these two. Try again, and you can see like right now, I mean, using Rust for the logic, but while I'm developing the UI, I get all the benefits of Flutter, right? And I can try if this works. Okay, so here we go. Here we see all of them. There you go. Now if I go here and I complete it, it goes away because the filter is on, and so all this works now, right? So again, this is just a bunch of UI code they have to write, but there's no real logic here, right? The logic is all implemented in Rust, and that's the main idea. Okay, so there's one thing that I want to fix before I move on. We're gonna add like a way to add it to do in a second. But there's one thing that is that's kind of crucial, which we are basically doing wrong right now. If you remember, I said that if something has a dispose method, right, at some point we actually need to dispose it. But here we don't. We just basically we get the to-dos, then we render, right, and then somehow we set state and we just forget about them, and we get a new set of to-dos, right? We get a new vector. We never clean up the old one, right? And that is a problem. So the way to do this is you can basically create getters and setters that take care of that. So let me just go through this step by step. So first of all, we're going to add a type annotation to this one so we can see what this actually is. Okay, cool. So now we're going to have and it's going to come clear while once it's kind of complete. So it's kind of hard to understand what I'm doing while this is going on. But basically what I'm doing is I'm creating a nullable version of to-dos, okay? And basically what I'm doing is we're going to basically implement a getter and a setter for those. So what we're going to do is, so this is a type for the getter, right? And we're going to say get to-dos, right? Okay, and what we're going to do is we're going to return those, but first we're going to assert that if you're getting them, they can't be null, right? So first we're going to assert that they are not null, and then we're going to return to-dos, and now we know that they're not null, so we can do that, okay? So now basically our app is happy again, but we never assign them, so it would actually crash, right? It would actually crash because the assertion will fail. Actually, we can just try that, and it would probably get an error message here. So if we change state somehow, well, oh, because we're still assigning them here. So if you don't do that, now we get, well, okay, to-dos is not null, shouldn't be null, right? So, well, so what we need to assign them, and we do this though via a setter, and this is a way that we can guarantee while we're assigning them that actually we're cleaning up the old value. Okay, so we're going to set them, and what we're going to do is if to-dos is not null, right? So we have the question mark there, then dispose them. And intelligence kind of sense kind of fails us here, but it's there. The method is there, and so then we assign only after we dispose the old ones, if they were set, right? Then we actually set them to the new value, and so now we can put the code back here that says to-dos equals model filter to-dos, right? The main difference here is that now it's not available anymore. It's actually a setter backed by a field, and every time we actually modify that field, we make sure that we dispose the old value if it was set. That's the main difference, and now things work again. You can see, well, disappeared, right, because it got completed, and we can see all of them. All right, so so we're pretty close to have the full app. What I'm not going to do, the full example, right? I'm going to actually put a link here again. This full example that's here has also a, let me show that. It has a, it has like a little draw app that allows you to complete all or restart all or remove all. We're not going to implement that here, but you can review the example to see how that will work. Additionally, like, well, this one we won't do, right? It's not really needed. That's pretty much all that's going to be missing. Okay. And now we want to at least implement this little plus here, right? We want to be able to add to-dos. And again, there's a lot of boilerplate needed for this. So basically, what you need in order to do this, you need like a text field controller, right? Because what we're going to do is we're going to press on the button, right? And then when we press on the button, we get like a pop-up that allows us to give the title of the to-do, and then we add it. So that's what we'll need. And what I'm going to do, since this is rather mundane, I will basically copy this function and just work through it, because it's not really necessary to understand how read works. So well, we're also missing this as a string. So basically, add to do title is something that is kind of state. I feel the way of doing this in Flutter is a little bit, well, I don't like it like too much. But basically what we're doing is we show a dialog, right? And we say, well, enter the to-do, and and we give it this controller. And so then when basically we press the text button, which means like, so the done, sorry, text button done, right? When we say we are done, and then basically we set the to-do title to whatever was entered into the text box, and we get it from the text field controller, right? And then in order to close it, the pop-up, we pop the context, and now obviously, or once we still have the button to implement here, but once we basically like close this and we get the result, then we update our to-dos. So let me actually implement this as well via copy paste, and I'll just walk through this. So these are the bottom bar, and then this one will be just in the scaffold because it's basically a floating action button. We put it in the middle, right, because it doesn't very well fit here very well. So we put it in the middle. So what we do is, like, when you press this button, we clear the text field controller, right? And then we wait for the dialog to open and the user to enter stuff and close, right? And then basically if the user entered the text and it wasn't empty, then we actually add this to do, right? Because we don't want to add empty to this. So now if I do that, you will see that a magic button appears, and we can enter it to do title. So we can say hello new, let me type this right, new to do. Press done, and then we have this extra to do here. Maybe make it a little bigger. And so we have this extra to do. We can complete it like all the others. And actually what we can do just for fun, when we actually added one, we can then also tell the model to print. So, right, we can print out, or we can debug print here, actually print, and we just print the updated model. Model.debug. Actually, we're going to put that in the build method, right? So we're going to true because we want it to be pretty. And so what we'll do is, like, every time the state changes, right? Every time we rebuild, we are going to do this. So now why is it not happy? Oh, because I'm missing this one. Okay, so cool here. And we can see, like, it built and it printed out immediately all the states. So this is also really useful, right? You can use the debug method from Rust. Don't have to implement anything extra. Now, if every time I change something, we get a state update, which is also kind of neat, right? You could also obviously write the state somewhere, but this is kind of nice. Now, if I add, like, obviously every time I do this, then just the filter changes. The actual to-dos don't change. Yeah, that is pretty much it. And now I can talk really quickly about the sponsorware idea. But if there are any questions, by the way, let me know. I'm going to make this move this over here so I can see the chat over here as well. Now, if there are any questions, let me know. What I'm going to do is real quick, because there were questions about this. I'm going to explain how this sponsorware works. So basically, what I'm trying to do is I'm trying to really make this a serious project. I feel there's a need for something like this, because there are more people like me that actually would like to implement their logic in Rust, but have this kind of thing where you just write your UI and you change things and updates really quickly, the perks that Flutter gives you, right? But it's basically not easy, right? As I said, I spent about 3 months, nights and weekends, implementing to where it is right now. There's actually also a status. Actually, let me put that in the chat. There's a status update here, and kind of a roadmap. So basically, I already spent a bunch of time, and it is not easy. You have to be very careful not to make mistakes, and kind of like you're deriving two different codes kind of from Rust, and so it required a lot of work. And I know that in order to keep it going, and to keep evolving and to keep maintaining and to fix bugs, will take a long other time as well. So I want to make sure that I can invest that time. And I cannot do that if there's no one basically financially supporting me at all. So that's why I decided to release the sponsorware, which basically means that people can sponsor me, and immediately after sponsoring me, you get access, right? But only the ones that are sponsoring me. So they can use it right away, and they can look at the code and play with it and do whatever. And once I reach 60 sponsors, which is where I'm thinking, okay, now I'm actually fine. I can, this is enough for me to keep working on it and for a longer time, right? Then I will open source it to everyone. And then everyone can have it. And then it will stay open source. Even if all the sponsors would decide to even drop, I would still leave it open source. And that's pretty much all I wanted to show. let's see if there are any questions. I'm going to post my Twitter here. So if you want to follow me on Twitter to get updates. Also, this is the homepage of Red, which I